In this video, I'll cover the mathematical topics of direct and inverse proportion. I'll first go through a brief overview, the conceptual overview, and then go to some practical problem solving. So let's jump straight into the video. Before I go to the mathematical problems of the concept of direct and inverse proportion, I just want to briefly overview the concept, the mathematical concept of direct and inverse proportion. So if I go to Google and search direct and inverse proportion with these keywords, so what is the answer? It says in mathematics, direct proportion means when one quantity increases, the other quantity also increases proportionally. So if one quantity increases, the other quantity also increases. And inverse proportion is the opposite exactly, which is when one quantity increases, the other quantity decreases proportionally, or essentially they move in the opposite direction. So this is the core concept of direct and inverse proportion. So if I now try to attend the first problem of the mathematical topic of direct and inverse proportion, and let's read the problem here. So what does the problem say? It says, yesterday it took 5 cleaners 4.5 hours to clean all the rooms in a hotel. So there are 5 cleaners yesterday. So it took 5 cleaners 4.5 hours to clean all the rooms. Okay. So there are only 3 cleaners to clean all the rooms in the hotel today. So today there are only 3 cleaners available. Okay, to clean all the rooms. So each cleaner, this is the second information. And the third information given is each cleaner is paid 8.20 pounds for each hour or part of the hour they work. So each cleaner is paid 8.20 pounds per hour. So the requirement of the question is how much will each cleaner be paid today? So if I check this problem, so I'll use my pen tool. So yesterday there were 5 cleaners and it took 4.5 hours for 5 cleaners to clean all the rooms in the hotel. So 5 cleaners collectively took 4.5 hours to clean all the rooms. So if 5 cleaners took 4.5 hours to clean all the rooms, how much time would have taken for one cleaner to clean all the rooms? Because one cleaner now has to do all the work of the 5 cleaners. So it would obviously take more time, much more time, 5 times more time. So it would take what? 4.5 multiplied by 5, which is 22.5. So for one cleaner, it would take 22.5 hours to clean all the rooms in the hotel, because he has to do the work of all the 5 cleaners. Okay. So this was the first information. And the second information given was only 3 cleaners are available today. So there are only 3 cleaners available today. And each cleaner is paid 8.20 pounds per hour. So if one cleaner is paid what? 8.20 pounds per hour. Okay. So if one cleaner is paid 8.20 pounds per hour, we have to figure out what? How much will each cleaner be paid today? So we have to figure out how much each cleaner will be paid today. So to figure out that, we need to figure out how many hours will each cleaner be active, or how many hours will each cleaner work today. Okay. So yesterday hypothetically one cleaner would have taken 22.5 hours to clean all the rooms. So 3 cleaners are available today. So if one cleaner took 22.5 hours, how many hours will 3 cleaners take? Obviously the hour will be divided into 3 cleaners. So it would be what? The time taken would be 1/3. So this is what? 22.5 means 45 by 2 and divide by 3. So the result would be what? 45 by 6, this fraction. So this would be 15 by 2, or 7.5. So 3 cleaners would take 7.5 hours today. So if 3 cleaners take 7.5 hours today, so basically each cleaner would have to work 7.5 hours, be active 7.5 hours. Okay. So if each cleaner is active for 7.5 hours, how much will each cleaner be paid? So each cleaner is active for 7.5 hours. So if they are paid 8.20 per hour, So each cleaner, so 8 point, let's say, let's use the eraser and use the drop pen tool again. So each cleaner would be paid what? For every hour, each cleaner would be paid 8.20 pounds. So for 7.5 hours, when each cleaner will be active, it would take 8.20 multiplied by 7.5, is multiplied by 7.5 or 7.5, which is what? If I use my pen tool or the calculator, 8.20 multiplied by 7.5, which is 61.5. So it would be, each cleaner would be paid 61.5 pounds today. Okay. So what I did here is, so for when one quantity, let's say 5 cleaners took 4.5 hours. So for one cleaner it would take, when the quantity decreases, one quantity decreases, the number of cleaner decreased and the time increased. So for this, say 3 cleaners available today, the time is divided, like each cleaner would have to spend 7.5 hours. Okay, the time is divided into 3. So each cleaner takes 7.5 hours today and they are paid 8.20 pounds per hour. Okay, so now as the quantity, let's say for each cleaner, the quantity again increased to from 1 to 3 and the time was divided, the time decreased into 1/3. Okay, so here is an example of inverse proportional. The first one was an example of like one quantity decreased and the other quantity increased, and the second one I got what? When one quantity, let's say for each cleaner gets 8.20 pounds per hour. So if he works 7.5 hours, when one quantity increases, the other quantity also increases. So there are examples of both direct and inverse proportion in this problem. If I now focus on problem number 2, it says, let's read the problem. It says P, a variable P, is inversely proportional to T. So when inversely proportional means when P increases, T decreases, and vice versa. So when T is 4, P is 12. Okay, so you have to find, what is the requirement? You have to find that the value of P when T is 6. So if I attempt this problem, so it says there are two variables, P and T. Okay, so when P increases, T decreases, because P is inversely proportional to T, and vice versa. Okay, so when P increases, T decreases, and vice versa. So when P is 4, T is what? T is 12. So you have to find the value of T. You have to find the value of T when P becomes 6. When P becomes from 4 to 6, or when P increases from 4 to 6, you have to find what T becomes, or what T decreases into from 12. Okay, so in order to figure out the problem or the solution to the problem, you have to figure out what is the proportion, what is the rate, how P is increasing from 4 to 6. So what is the increase from 4 to 6 in terms of percentage? It's a, from 4 to 6, it's a 50%, it's a plus 50% increase. It's a 50% increase, or a plus 50% increase from 4 to 6 of the variable P. The value of P has increased 50% from 4 to 6. So the variable T should decrease 50%. The variable T should decrease 50% from 12. So what would T become if it decreases 50%? So you have to first figure out what is 50% of 12. What is 50% of 12? 50% of 12 is 6. Okay, so T should decrease by minus 6. So what should T become? from 12 to minus 6 means 12 minus 6, which is 6. So T should decrease from 12 to 6, which is minus 50%. Okay, so when P increases plus 50%, T should decrease minus 50%. If I now focus on problem number 5a, problems 3 and 4 are very similar to problem 2, so I'll skip them and I'll go straight to 5a. So what does the problem 5a say? It says, at a depth of x meters, the temperature of the water in an ocean is T degrees Celsius. So at depths below 900 meters, T is inversely proportional to x. So the formula is given as T is equal to 4500 by x. So if T increases, x decreases. So you have to work out the difference of temperature of the water at a depth of 1200 meters and at a depth of 2500 meters. So the temperature difference at depths 1200 meters and 2500 meters, you have to measure the difference of that temperatures of those two temperature points. Okay, so if I use my pen tool, so it says what? T is inversely proportional and the formula is given as what? T is 4500 by x. So T is what? 4500 by x. So it's clear that T is inversely proportional. So if T increases, x will decrease. Okay, so x is the depth in meters, depth, and T is the temperature in degrees Celsius. Okay, so if x is what? Beyond 900, this formula applies. So if x is 1200 meters, then T is what? T is 4500 by 1200, right? So this would be what? 45 by 12, which is roughly what? 45 by 12 means it's both are divided by 3, so it's 15 by 4. Okay, so this is the temperature, so which is roughly what? Around 4 degrees Celsius. Okay, so in the depth 1200 meters, the temperature is around 4 degrees Celsius. So this is, let's say this is T1, and T2 is what? Let's say 4500 by, now the depth is what? The depth is, that you have to measure is 2500 meters. So now the depth is 2500 meters. So you have to measure the temperature T. So this is what? 45 by 25. So 45 by 25 can be represented as 9 by 5, right? So it is roughly around 2 degrees Celsius. So the temperature difference, let's say diff, the temperature difference is what? 4 degree minus 2 degrees, so it's round about or roughly 2 degrees Celsius is the difference of temperature between 1200 meter depth of the sea and 2500 meter depth. Now I'll focus on problem number 8. I'll skip 6, 7. So these are very straightforward and similar to what I have done so far. So I'll focus on problem number 8 and read the problem. So it says, the diagram shows, there is a diagram here, it shows the position of a tap when fully off and on. So when it's fully off, it is in this state, and when it's fully on, it goes direct opposite, which is 180 degree turn. So this is what it says, tap is fully on when the angle of turn is 180 degree. So when fully on, the water flows 14 liters per minute. So when it's fully on, then it's when it's fully on in this state, 180 degree turn from off, the water flows 14 liters per minute. The rate at which water flows is in direct proportion to the angle of turn. So according to the angle of turn, the water flows x liters per minute. Okay, so it's when it's fully turned on, it's 14 liters per minute. So when the tap currently is turned on 135 degrees, so the question says the water flows into the tank with a capacity, the tank capacity is 79.8 liters. So the question is, will it take less than 7.5 minutes to fill the tank? So I have to figure out the time, the number of minutes it will take for water to fill the tank. Okay, so if I attempt this problem, so I go to the problem. Okay, so now if I use my pen tool, so what are the information given here? So when it's fully on, it's 14 liters, the water flows at 14 liters per minute. So I have to figure out how many liters water flows when it's in a 135-degree state. Okay, so when it's fully turned on, or in a 180-degree state, 180-degree turn from off switch, water flows at 14 liters per minute. 14 liters per minute. So how many liters does the water flow when the tap is turned on in a 135-degree angle? So this is what how many liters per minute does the water flow? I have to figure out that. So how many liters would, for 14 liters is per minute is flown when the tap is turned on 180-degree. So for 135-degree, so for 135-degree turn, or if I just use the degree here and the liter per minute here, so for 135-degree turn, the water, if I use the unitary method kind of, so if I use the unitary method, it would be what? It would be 135, the proportion is what? The direct proportion is what? 135 out of 180, right? 135 out of 180 multiplied by 14 liters per minute. Okay, so 14 liters per minute. So it would be what? If I divide both by 45, it's 3 by 4, right? And if I divide 4 and 14 by 2, it's 7. So 7 3 is 21 by 2. So it's 21 by 2, or 10.5 liters per minute. So water flows at 10.5 liters per minute when it's in a 135-degree state. Okay, so this is the key information. So how much time will it take? So the total capacity is 79.8 liters. So the total capacity of the tank is 79.8 liters. Okay, so if the total capacity is 79.8 liters and water flows at 10.5 liter per minute, so how much time will it take? So if the time is t, the time would be what? 79.8 liters divided by 10.5, okay, or 10.5 liters. This is liters and this is liter per minute, right? So this would be what? If I use the calculator, so 79.8 divided by 10.5, this is 7.6. So it would be what? 7.6 minutes, which is greater than 7.5 or 7.5 minutes. So the original question was, will it take less than 7.5 minutes to fill the tank? The answer is no, it would take slightly more than 7.5 minutes, which is 7.6 minutes. Okay, so this is the answer. I hope you get an idea of how you can solve the mathematical problems regarding the concept of direct and inverse proportion. So in the next video, I'll cover some more problems, some hard problems of this topic. So stay tuned for that.